In the heart of America's racing capital, a massive football stadium must come down without destroying the busy convention center and active rail line that lie only a few meters away. This colossus is tough enough to hold 60,000 extreme fans. But now, it's up to a team of demolition experts to tackle 46,000 tons of concrete and steel and to contain the destruction. Indianapolis, Indiana, a sports fan's oasis in Middle America. Home to the Indy 500, the Colts, and these two football stadiums. In 2008, the hometown Colts moved across the street to the ultra-modern Lucas Oil Stadium. Now, the convention center plans to double in size, and the RCA Dome has got to go. But it won't be easy. The dome stands nearly 60 meters high on 2 city blocks of prime real estate. This colossal structure will be obliterated using high explosives. But the stadium's not just huge. It's surrounded by other big players, a convention center, a high-traffic railroad, and a major sewer line. A disaster could cost billions. The Indiana Stadium and Convention Building Authority hires Controlled Demolition Incorporated to manage the risks. A family business from Phoenix, Maryland. They're experts in the field of explosive demolition. They've taken out some of the most complicated structures in the world. But this time, they're up against an all-star. To keep the winning streak alive, they'll have to slice through almost 2.5 meters of solid concrete, take on huge expansion joints, and drill 849 holes. And there's still no guarantee they'll contain this giant. The team will load 277 kilograms of explosives and lay more than 4 kilometers of detonation cord. Now it's time to implode this massive stadium. But can this skillful demolition team keep its destruction from spreading?
CDI, this is going to be your final clearance.
3 months of prep comes down to this.
Here we go. 5, 4, 3, 2, 1. Fire.
Mark Loiseau is CDI's demolition designer. He heads up thousands of implosions, but he's never seen anything quite like this.
It's easily the most complex job that we've ever done, and it's probably the riskiest job we've ever done. It's not one structure, it is 8 separate structures.
Located in the downtown core, the dome is bordered to the north and west by the convention center, a main source of revenue for the city. To the east, the Pan Am building. 12 stories of office windows face the dome. To the south, a main railway. Every day, dozens of trains travel along these tracks. And just beneath the dome, a nexus of sewer lines. The oldest was built more than 100 years ago. If disturbed during the blast, over 1,500 buildings could flood with raw sewage. Mark bets a series of plays will keep the RCA Dome in bounds. The stadium looks like an oval. Expansion joints, united under a single poured ring of concrete, hold the building's 8 sections together. Crews will pre-slice the ring of concrete and strip the expansion joints. Next, the team will load explosives into columns on each of the stadium's 4 levels. Then, they'll stagger the explosions so the 8 sections fall separately and away from the neighbors.
It's a lot like stadium origami, just to try to fold the pieces in on top of each other.
It's the art of demolition. But before Mark's team can get started, a demolition crew will remove the RCA Dome's air-supported roof. Only 5 major stadiums in the world are built like this. Round-the-clock fans and 16 intersecting cables hold up fiberglass-based fabric. Tom Shaley's job is to deflate the roof safely.
Huddle up, huddle up. Although saying let the air out of the roof sounds very simple, we got to keep everybody out of here for any catastrophic thing that could happen.
He worries that if the air disperses too fast, the roof will collapse. The uneven tension could snap these massive cables, slicing anything caught in their path.
The all-important control booth.
This is where Tom's team will control the roof's descent.
Go ahead, Tom.
Crews shut off the fans one by one.
Go off here in a bit.
The drive's ramping down, David.
Kill it.
The dome begins to deflate.
Setting number 5 down.
So we have no fans on now. There are no fans on right now.
The roof isn't coming down fast enough. The team was overly cautious.
I need 4 doors open at gate 1.
To compensate, the crew opened the stadium doors so the air will flow out faster.
Go ahead and open them all up, and we're just going to bring this thing on down now. There's serious holes in here now. When you can stand here and watch it move, you know it's coming down pretty good now.
It works. The dome falls more than 50 meters in about 35 minutes. The team has safely deflated the dome. Now, the physical labor begins.
That sheet's about ready to fall that way. You need to get your basket over here.
Copy that. Keep going that way, and I'll stay on this side. Yeah.
Workers painstakingly cut thousands of square meters of fabric so it can be recycled. This job will take 2 months to complete. With the roof gone, the electrical fans are no longer necessary. Crews shut off power to the dome so that the demolition teams can work without hitting live wires. Mark arrives to inspect the RCA Dome and finalize his demo plan. The walkabout seems routine until he reaches the south side. Mark's expert eye hones in on this, the stadium's press box. He sees the structure is more complex than the building plans let on. It stands 9 stories off the ground and was built more than a decade after the dome.
down to here to hang that out. to
Mark
try
and his
get
brother
it to
Doug
rotate.
need to take a closer look and see firsthand what the press box is made of.
Just open it all up. I don't believe the plans anymore.
The skid steer rips open the exterior wall. His inspection confirms the add-on is a problem. Here's what he's up against. First, it's supported by steel columns. The rest of the stadium sits on concrete and rebar. Second, it's not fully integrated into the dome.
All right, so you're talking about going up here to, and I agree with you.
Right here.
These differences mean it may not fall with the rest of the structure on shot day.
Rotate it up here. See right here, this was the original building column. This was part of the building column, and then this is a new structure. Right here, and all of this. This is a new press box that they put onto it, and it's freestanding.
This design causes a problem because the press box sits almost on top of a main railroad. Up to 50 trains a day run in its shadow. If the press box lands on these railway tracks, shipping through the Midwest will be brought to a standstill. A tricky ninth piece complicates Mark's 8-piece puzzle. He'll have to rework a key part of his plan. Sports stadiums date back to ancient times, when the Colosseum was the hottest ticket in the Roman Empire. Built by Emperor Vespasian almost 2,000 years ago, this megastructure exploited the Roman arch. 240 of them pioneered the distinctive stadium shape. This design allowed some 50,000 spectators to witness the carnage of gladiatorial matches. The games have changed, but the fan frenzy remains the same. The RCA Dome entertained spectators for nearly 25 years. Now the fans and their team play at the Lucas Oil Stadium. And it's up to the demo crew to take this empty structure down. The main on-site contractor, Sabre Demolition, will remove the entire lower bowl so the upper part of the stadium has a place to land on implosion day. They recruit an army of massive machines. The excavator is their foot soldier. They weigh over 45,000 kilograms and act like juiced-up Swiss Army knives. The claw on the end of the arm can be custom fit to each demo task. This special high-reach excavator has an extra long arm, or boom, and is fitted with an attachment that can rotate 360 degrees. These precise jaws target higher rows of seats, pinch, and pull them off the stands. When it's time to get tough, workers attach a hydraulic shear. Its blades can crunch through more than half a meter of solid concrete in a single bite. To demolish a concrete block wall beyond the reach of the shear, the team improvises. An excavator grabs an I-beam. From the ground level, the operator can't see the wall. Mark keeps the beam on target. more than 7,000 tons of metal will be recycled. Mark plans for the dome to fall in 8 pieces on demo day. The straight sections will have to fall before the corner sections, or the pieces could wedge up against each other. To start this process, another crew attacks the dome's ring beam to sever the concrete oval. Workers use an aluminum diamond blade wall saw to cut through almost 2.5 meters of concrete. These diagonal slices are called fallout cuts.
So we need to be able to make sure that when we go 3, 2, 1 fire, this flat section is free to move right away.
It takes a whole day to make each 135-degree angle cut. Crews go one step further to complete the separation job. Below the ring beam, the 8 sections of the dome are secured by expansion joints. These are flexible connections, built so the stadium could adjust to the weight and movement of tens of thousands of sports fans. The team must remove portions of these expansion joints to make room for the sections to fall in. On the south side of the dome, Mark still grapples with the unpredictable press box. He's come up with a partial solution. Heavy-duty cables will anchor the structural add-on to the rest of the dome. The cables should pull the press box into the center of the dome and away from the railway tracks. But for this plan to work, Mark still has to take care of the press box's steel columns. CDI's no stranger to steel structures, or Indianapolis. 2001, the crew reduced Market Square Arena to rubble.
Three, two, one.
Once home to the Indiana Pacers, more than 200 kilograms of explosives brought the arena down in 15 seconds. It was CDI's first implosion of a steel-framed dome. But the RCA dome's more than 3 times bigger than Market Square. To attack this giant, Mark's team will target columns on all 4 levels of the stadium. At field level, the inner columns will be completely destroyed. The outer columns will be partially demolished to create a hinge to fold the dome inward. A set of charges in the upper seat bends will soften the front section of the risers. As the stadium falls, explosives in columns on the upper levels will break up the structure further and keep it moving. But before they can load the explosives, crews have to finish prepping the dome. They continue to strategically strip from key areas to pre-weaken the stadium. Workers chip, torch, and tear away at the dome until it's a shell of its former self. This work will help CDI direct the stadium inward on shot day. The next step in this process is called column chipping. A rebar cage reinforces each of the 380 concrete columns that support the dome.
Remember when you were a kid, someone would come and tap you in the knees? That's all that we need to do. We just need to destroy the structural integrity of this piece of rebar, this piece of rebar.
To do this, a skid steer with a hydraulic hammer chips away at corners of the column to expose the rebar. Then the team uses a cut saw to slice the horizontal bands of steel. This creates a point of weakness, so the rebar will bend when the dynamite explodes.
If we can remove those corners, expose that rebar, and cut them, we can reduce the amount of explosives we use and increase the performance.
Every column that's prepped for explosives will be pre-weakened. After months of demolition, the RCA dome looks like an open pit mine. Hundreds of columns have been drilled and wrapped with protective fabric. This geotextile material will stop flying debris on demo day. The stadium is finally ready for explosives. Crews will now load more than 1,000 sticks of dynamite into the dome.
Okay.
To meet the implosion day deadline, they have to start soon.
An issue that
The first explosives and the magazine to store them arrive.
Got a hard hat? Yep. If you guys just want to follow me in, I'll pull you around our bunker and I'll get an excavator and we'll start getting this unloaded.
This shipment contains more than 200 kilograms of dynamite, as well as detonators and detonating core. Safety regulations require that this quantity of explosives be stored in a steel magazine at least 195 meters away from occupied structures. This is just the beginning. The team expects 2 more truckloads before the job is done. But some of this dynamite will see action before shot day. The team prepares to test the strength of the RCA dome. They will detonate explosives in several columns to determine exactly how much dynamite they're going to need on demo day. Because as miserable December weather sets in, the team needs to fine-tune its explosive plan. Cold temperatures make windows more vulnerable to the intense pressure generated by explosives. This powerful force, called air overpressure, forms when explosives detonate. If more than one charge goes off at the same time, these energy waves combine and amplify. It will take hundreds of blasts to implode the dome. The potential force could shatter thousands of windows. The team must manage this air overpressure. The simplest way is to use as little dynamite as possible. Mark needs to determine the minimum amount of explosive power he'll need to take the RCA dome down safely. There's only one way to do this. Mark and Tom will test the stadium's strength with live dynamite.
Yep.
This test shot will be their first chance to see how the concrete columns react to explosives. Tom loads 5 columns. Each contains different configurations of dynamite.
When we come in the morning, it's, pardon the pun, but bang, bang, bang.
Crews evacuate the RCA dome. Mark and Tom wire their final connections. They're eager to see what this experiment will reveal.
A couple of the columns were undershooting intentionally so as not to displace too much of the concrete. If you overshoot a column, you don't learn anything. You simply know you could have used less. It's better to undershoot it and add a little bit more to get the results you want.
Minutes before the blast, Tom takes position outside the stadium. Only company president Mark stays inside to witness the shot.
All right, CDI, everybody hold tight. We're just waiting for the light.
Okay, Tom, I've got about a minute.
All right, I'm at 1 minute.
I'm a minute ahead.
Okay, here we go. 5, 4, 3, 2, 1, fire.
Mark waits for internal delays within the detonators to burn. It's a long 9.5 seconds.
Mark Milazzo, are we all clear?
All set to come back in, Tom.
All right, traffic's rolling.
There's a problem.
One fell over.
One of the columns that was undershot is toppled.
It came this way.
Worse, a column that he thought was structurally identical stands upright.
I think that's
Tom
a 4.
explains the load to Mark.
I think that.
That charger's probably 12 inches back.
In 12.
Yes.
This was 3 3/4.
Mark's irritated. The test shot is over, but the results are inconclusive.
Not sure what we learned here, Tom. I wish this hadn't fallen.
I'd say it's
He still can't predict
see it.
exactly how the columns will react on implosion day.
The stadium was built by people. It was tied up by laborers. All the rebar connections were made. Concrete is poured in different days in different batches. Always small anomalies. Your hole right there.
These small differences mean big problems for CDI. The team will load 245 columns, and they'll all have to fail for the demolition to succeed.
Yep.
Mark must now use more explosives than he wanted. This means the air overpressure will be greater, so he'll need to find another way to counter the destructive force.
That's tied.
CDI has come up against big sports stadiums before. In 2001, the team took down Pittsburgh's Three Rivers Stadium. The 59,000-seat arena broke into pieces as it crashed down. CDI directed 3 sections outwards to spread out the force of the impact. Three Rivers was comparable in size to the RCA Dome, but didn't have an aging sewer line beneath the field. And this time, the crew doesn't have the luxury of space. All 8 sections of the dome need to fall inward on top of the underground sewer. The drainage system runs less than 3 meters beneath a large section of the stadium. If ground vibrations from the implosion disturb this century-old system, the city could be swimming in more than 56 million liters of waste.
It comes down like a hatchet, and that hatchet is going to hit right at this point.
This infrastructure disaster could cost billions. CDI can't risk the backlash. They need to protect these sections. Here's how. Crews use on-site debris to put a 2-step plan into motion. First, excavators gather columns and beams that supported the lower bowl. They stack these over the sewer lines.
You'll put certain beams this way, then some this way, then back and forth. Lincoln logs, if you had those when you were a kid.
They fill this makeshift frame with concrete rubble. These piles of debris will work with stadium risers, what's left of the lower bowl, to cushion the sewer from the inevitable blow. The second phase of this plan turns other columns into shock absorbers.
structure were to hit it, it'd be like a hammer hitting a nail. We drive it straight into the ground. By taking this machine and this hammer and softening it up, we take that nail and we turn it into like a spring. So as the structure comes over, it hits it and it'll absorb that energy and take the impact off of the sewer.
To create these springs, excavator crews systematically hammer away at columns. More CDI workers arrive. It's time to load the dome with dynamite. Every high-velocity stick weighs 225 grams and has the power to shatter 3/4 of a cubic meter of concrete. The team will use 1,224 of these sticks on 4 different levels of the dome.
The cart of doom.
Mark's daughter Stacy and her sister Devin prepare to load the columns. To reduce the risk of flying debris and air overpressure, they need to harness their explosive power. A special technique called deck loading helps them get the most bang for their explosive buck. These columns are very deep. Instead of filling the entire length of the pre-drilled hole with explosives, they use pre-measured bags of sand to separate short pieces of dynamite. This distributes the explosive energy throughout the column. When the charges go off, the released energy seeks the path of least resistance. It travels to the dense rebar of the column and vibrates the metal cage. This motion breaks up the concrete. To maintain their focus, the team works in silence. They still have to load and wire hundreds of kilograms of explosives, and they have less than a week to do it. But deck loading will not work here. The press box is immune to dynamite.
If we put a stick of dynamite here and detonated it, most of the energy would go to the area of least resistance, which is away from the column itself. So we use something called a linear shaped charge.
These shaped charges contain RDX, one of the most powerful explosives in the world. When detonated, the copper jacket aims energy directly at the steel. The powerful force slices with surgical precision. To install these charges, workers pre-cut each steel column. Then they secure the explosives. A final team encloses the shaped charge system with custom-made plywood boxes.
The last thing that we need is a piece of copper taking off, say, towards Lucas Oil Stadium at 23,000 feet per second. So this box will help break that down and reduce the fly of debris.
Crews will position 52 shaped charges at the base of the press box. Upstairs, Mark checks his cabling solution. 10 steel core cables now anchor the add-on to the rest of the stadium. Each is almost 2 centimeters thick and can pull more than 15,000 kilograms.
It's a concrete section that has the weight. That's where the energy comes from. So when the concrete section rotates in, these cables are going to serve to drag the steel press box section inward away from the railroad tracks, we hope.
Mark has done everything he can with the press box. But in the upper part of the dome, cold weather slows CDI's progress. Mark's plan called for dynamite to be loaded in holes drilled in the upper seat beds. But it can't be done. These vertical holes have filled with rain and frozen.
There's a lip of frozen material around the hole. I can't get the charge in the hole. Let me see if I can't beat it out.
The dynamite cannot be loaded. Kevin and Jimmy need to break the ice. Kevin uses a wooden loading pole to chip away at a hole. He tries one last time. it works.
Got it, Jimmy. You're the man, Kev. You're the man.
Kevin's makeshift solution pays off. The two press on until all 21 vents are loaded. But other key work has been called off. Here, the expansion joints that connect the 8 pieces of the dome cannot be completely stripped. To separate the stadium, Mark planned to remove parts of these expansion joints. Concrete slabs at each of the 8 junctions must be taken out. The crews were able to remove the lower slabs, but they can't reach the higher levels safely. If the excavator moves close enough to work on the upper slabs, the machine's operator will be in the path of falling debris. The team will not risk an accident. They call the removal off.
The fact that they cannot come through here and get these slabs out changes everything in the 11th hour. So now we completely have to rethink this.
Because these slabs could jam between the stadium's 8 sections and disrupt their fall on shot day. If they hold these sections up, even for a second, CDI's intricate detonation sequence will be jeopardized and place nearby properties at risk.
If you take a flower petal, we're trying to pull these flower petals in. If we don't get the correct motion, the correct inclination inward right away, and they start to veil vertically first, now our flower petals are going out into the street, into the convention center, across the railroad tracks.
Danville, Virginia. Another demolition contractor planned to take down a smokestack like this. Here's what really happened. It hesitated and fell 18 meters off target, straight towards a crowd of onlookers and nearby homes. Here, the RCA Dome's close neighbors mean a similar mistake could cost millions. But there's no time to manually remove the expansion joint slabs. So Mark decides to take them down using explosives. Unfortunately, it requires a complex detonation plan. This is how it will work. Every 15-centimeter thick reinforced slab rests on 2 floor beams. 2 columns help support each beam. Mark adds a layer of timing to his detonation sequence, so columns on one side of the expansion joint fail before their structural counterparts, allowing the slabs to slide down and out of the joint before the stadium's corner pieces fail. But there's a price. These last-minute changes complicate the detonation sequence and increase the amount of air overpressure. If too much explosive energy is released during the implosion, it will combine and form a powerful and dangerous air overpressure wave. If too many of these waves combine, nearby windows cannot be protected. Mark needs to further adjust the detonation sequence. He inserts micro delays between selected columns. These should stagger the explosions enough to keep the air overpressure waves under control. Tomorrow, the implosion sequence should happen like this. A single pulse from outside the dome will trigger the implosion. This pulse will travel to 8 primary delays positioned at field level. These primary delays will ignite 8 detonation cords. Each pulse will travel to a separate section. The south section and press box should be first to topple inward. A half second later, the north side. Then the 2 remaining straight sections, followed by the corner pieces. Crews pull their equipment out of the stadium, setting the stage for the RCA Dome's final showdown. It's shot day. Tom verifies that the RCA Dome is empty. He carefully checks the detonation circuit one last time to be certain crews connected the wiring correctly.
Everything looks good.
He will be the final fan to leave the stadium.
Thumbs up.
The structure is clear and empty.
The team gathers for one last huddle.
What was a very direct project has become very complex. And we have done the best we can with what we've got to work with. I think it's going to be enough. But this might not necessarily be the crisp, clean job you're used to seeing.
Demo designer Mark takes his position. He'll be watching to see if his plan can contain the destruction. The neighboring convention center sits just 3 meters from the dome. Will piles of debris laid by the team be enough to keep columns from slamming into the center's wall? To the east, can the delay sequence protect the Pan Am building? 12 stories of windows are exposed to the blast. To the south, the press box looms above the adjacent rail line. Will the shaped charges cut the steel so the cables can pull it away from the tracks? And out of sight, but not out of mind, will Mark's efforts to cushion the sewer less than 3 meters below the stadium keep the century-old system intact? It's the moment of truth.
Jimmy, I am in the red.
Here we go. 5, 4, 3, 2, 1, fire.
The RCA Dome comes down in 25 seconds. From a distance, the implosion seems to go off without a hitch. At the very top of the stadium, the concrete ring beam pre-cut by the crew breaks cleanly as the stadium begins to fall. Just below the ring beam, Mark installed delays to drop the concrete slabs in the expansion joints. Columns on the right side fail before the ones on the left. As the slabs slide, the expansion joint folds, creating space for the corner sections to fall. Mark also positioned delays so the 8 sections would fall at different times. As predicted, the straight pieces come down. The corner sections follow. The press box was a big concern. Structurally different from the rest of the stadium, steel columns supported this add-on. The team installed shaped charges to sever these metal supports and cables to pull the press box inward. These powerful explosives go off. Blasts of energy send the copper jackets flying through the protective wooden boxes. As the south section falls, the cables tighten and pull the press box in. The railway tracks escape damage. At field level, The team's sewer protection plan also pays off. The upper half of the dome crashes down and meets the risers before it hits the ground.
Got a couple of sections here.
Mark and Tom want a closer look.
They're up in the air, but for the
They approach the site to inspect the piles of debris, or berms, that crews laid to shield the convention center from the implosion.
And this west side just jumped.
I couldn't ask for anything better than that. Most of what you see are the berms that we placed to backstop these columns so they wouldn't hit the smooth concrete slab and slide. Did their job.
But was CDI's complex detonation sequence enough to spare nearby windows? As the team removes protective covering from a neighboring building, Mark receives word the Pan Am windows withstood the blast. City crews also check in. The sewers have not been damaged. Excavators begin to clear the rubble. Less than 25 years after it opened, the RCA Dome has been sacked. The Lucas Oil Stadium sits uncontested and now dominates the Indianapolis skyline. And the sports fans' quest for the ultimate stadium continues into a new millennium.